So, have you want to take over?
Yeah. Just give me a second to share my my screen. Give me a second. Sharing. There. Can you guys see my screen?
Yes, I can.
Okay. So, hello everyone. My name is Javier. I'm part of ARM's OSS team since last quarter last year. I work on Cambridge main campus, and I'm one of the TFA developers there. So today, as Bipin just said, I'm going to give a brief introduction on the new Cmake build system that we are developing for TFA, right? I'm going to go. I'm trying to keep myself short. I don't want to go for more than half an hour. This is the table of contents that I want to show. So I'm going to start with talking about the motivation, what drove us to start working on this new build system. I'm going to give a brief introduction to Cmake for those who doesn't know about that, well, who are not familiar with that. I'm going to talk about the integration of Cmake into TFA, the approach that we are following, all the features that we needed to add, well, all the features that we needed for the framework and how did we add them. I'm going to go through an overview of what we have till now. Going to explain a couple of examples, and then I'm going to talk about the current status of the build system and the future plans that we have. Okay, so then let's get started. So what is the motivation to build a new build system for TFA? So well, as you all know, at the moment, the current build system is based on GNU Make, which at the time the project was born, it was sufficient. But now as the project is growing, this build system is getting very hard to scale. So we have a large amount of different options and dependencies on the project. It can be very difficult not to break some parts of the system when we try to add support for other parts, for new libraries. Another thing that sometimes can be a bit annoying is the fact that with the current build system, for instance, we cannot detect change of the configuration. So if we want to rebuild TFA with different options, we need to clean the whole workspace and rebuild again. And yeah, there's some other gotchas here, and those were some of the most important ones. So we decided to use Cmake because it has been already successfully used on several other projects at ARM. Is more scalable than the current implementation. It is able to handle dependencies easier. For instance, we have this feature that Cmake has, the transitive dependencies, that it proved to be very useful. It is able to detect changes in the configuration. It is more portable, so we can use Cmake with different operating systems and with different architectures seamlessly. And we have a richer set of features compared to the current build system, and those features can be very useful for us in the future. So what is Cmake? So as many of you may know by now, Cmake is a tool that describes and generates build systems. So we have a set of files with a description of the build system that we need. in something that is called the Cmake language. So this makes the build system, as I said before, OS, compiler, and target independent. So we won't have any kind of dependency that we can have with GNU Make. Cmake is able to generate build systems using the description that we gave of that build system and using a generator, which means that once we have the description of a build system, we can have an actual build system built on Makefile, Ninja, VS, any build tool that we want to use. It's agnostic in that sense. It also comes with some cons and some gotchas. For instance, the Cmake language itself, it can be a little bit a little bit hard to learn, and also it has a lot of features, and sometimes it can be a little bit confusing when using it. So yeah, the next slide is a little bit on the Cmake workflow. So Cmake uses as an input a file called Cmake list txt. So this file contains a set of definitions that are used for the build system, and also contains a set of modules or subdirectories that contains another set of files, of Cmake files, with the targets that we want to build. So this Cmake list and the rest of Cmake files will generate a cache, what is called Cmake cache txt. So that file is a file which is persistent across different runs, and it pretty much contains all the variables that were gathered from all the input files. So the workflow is divided into two steps. The first step is the configuration, in which Cmake just reads all the Cmake list txt files and the rest of Cmake input files, and then generates the cache. And then from that cache, it just generates the build system itself. In our case, it generates a build system based on GNU Make, so it will generate a Make file. Then the second step is just build the project as we will do it with any other build system. So in our case, we will just run Make, and that's all. Because Cmake takes care of all the arguments and all the different options, we wouldn't need to pass any extra arguments to Make. Just calling Make should be able to build the system for us. So now that I gave you a bit of context on what Cmake is and how does it work, so there is how we integrated this into TFA. So as I said before, one of the major cons of Cmake is the language itself. Sorry, did someone say something? Okay. So yeah, as I was saying, one of the major cons of Cmake is the language itself. So we decided to create all Cmake framework. Decided to create our own Cmake framework. Sorry. So this will be a host in its own repository inside a trusted framework. And this will be a project itself that will contain the same portion of all the Cmake scripts that we will need in order to create a build system for TFA. So it will contain modules that will be common to all the libraries and submodules in TFA. It will contain constants, variables, and any other artifact that we may need. This will be a project, a completely independent project, aside of Trusted Firmware itself. So it will have its own repository. It will have its own CA test, and everything will be completely separated from TFA. So that would be the first part. The second part is what we call the build definitions. So the build definitions are project-specific Cmake scripts. Those are integrated into the current trusted firmware. So and those rely in the Cmake framework that I just explained. So pretty much what we do here is we download the Cmake framework, and then once we are in trusted firmware, we call Cmake, and then TFA should be able to find where we have the Cmake framework on our system, and start importing all the scripts that we have on the Cmake framework, and start using all those scripts and all the artifacts that we have there on the scripts that would be actually in trusted firmware, right? This will allow us to introduce any new feature or any bug fixes in the Cmake framework independently of trusted firmware. And in the future, it could potentially even allow us to reuse this Cmake framework in different projects. So for this implementation, we decided to follow a two-phase approach. At the moment, we are in the middle of phase one. So the first phase suppose that we are now modifying TFA source code. We keep the project structure and modularization untouched. So the build system logic, the Cmake build system logic, will be similar to the one that we've already have right now. So this will allow us to have some coexistence between the Cmake build system and the current Makefile one. So we can continue on the development without causing too much disruption into the current project. Because of this, we are not going to be using all the features that Cmake has to offer. So once the first phase is done, we are going to move to the second phase, which encompasses a refactoring of TFA, of modules that may need it, to allow a better modularization and clear the APIs and dependencies, so we can use all the Cmake features, such as the transitive dependency propagation and some other features that will make our life easier. Okay, so this second phase is for the future, and yeah, so far we don't have to worry too much about this now. So what features does our Cmake framework need? So we needed to be able to have a structured description of the configuration and all the parameters and of all the settings that we want to use, such as the build options, the defines, the flags, etc. So for that, we came up with a set of utilities that are implemented on the Cmake framework. So these utilities are, for instance, a map, which is a sort of key value pairs. We came with what we call groups, which are a collection of maps. So we can map several related keys into interrelated collection of keys. And then we also came up with an assortment of config files that will put everything together. We also needed a way to describe the targets that are going to form our system. So we want to say we want to define what are we building, what source files do we need, which libraries do we have to link to, how to configure a linker script, etc. So all this come with something that we call the target API or the STGT API. So this is some sort of a wrap into Cmake functions. They use the setting groups that I mentioned on the point above, on the point before, and with this we just have an API in which you can define all that I mentioned before. So what do we want to build and how? And for that, we will use, as I will show before, as I will show later, we will use the groups that I was talking about, of which I was talking before. We also needed some way to abstract the compiler and the tool chain that we are using. Because depending on in which platform we are building, we may need to invoke all those tool chains in a different way. So for that, we came up with a set of functions that wrap all the compiler functionality. So we just need to define some parameters for a compiler, and then excuse me, and then from the build definitions, we call those compiler functions, and they will take care of everything. And finally, we also needed a way to define what external dependencies do we have. For instance, do we need to build an external tool such as FibTool or DTC? Do we need to install a third-party library, etc.? So for that, we also come with some modules based on find package that are able to take care of that for us. Okay, did I hear someone trying to say something? Okay, so moving forward to the next slide, this shows an overview of the framework. I don't know if you can see my cursor here on the screen. So we have on the right side, on the right-hand side, we have a set of artifacts such as the config files, the platform package, and the tool package. Those are provided by the build. Those form the build definitions. Those should be on the TFA repository, right? So the config files define, as the name suggests, define configuration options, defines C flags, linking flags, etc. Then we have the platform packages, which are files, Cmake list txt files, which defines the platforms. For instance, we have one for FTP, another one for Euro, etc. Then we have some configuration files, which help us to define which tools do we need in order to build the system, which external tools, such as the FibTool or device tree compiler, etc. On the right hand side, we have the Cmake framework components. So we will have the framework utilities such as the mapping, the grouping that I explained before, etc. The STGT also. Then we have the compiler interface that I talked about before, which abstracts the use of a compiler. And then in the center, we have the target files, which defines how do we build every one of the different images of the system. So for instance, how do we build BL1? How do we build BL2? How do we build the different libraries, etc. So those files make use of the config, platform, and tool packages, and make use of the Cmake framework, and then generate the final binaries that we were aiming for. So as an example of everything that I was explaining, we have here a group example. So this thing that I have here on the screen will correspond to some build definitions. And here we are creating a new group called compiler, right? And then on this compiler group, this will be a collection of different keys related to the compiler options that we want to use. So for instance, we can see that we have, we use a key of type C flag, and it's the name of the key is -G. Another one of type AS flag, and the key is -G as well. And then we have several other C flag keys. Then on the second snippet, we can see, for instance, that we define another group for the hardware platform, right? And for instance, so we not only can add keys, but we can also assign them a value. So on the second snippet, we are using keys with values assigned to them. So for instance, we can see that the first one is of type config, and we define a key called FVP use gig driver, and we assign the value FVP gig v3, and the same for the timer, for the cluster count, for the CPUs per cluster, etc. So this will pack all the different options into related groups, into logical, into groups that have the same that belongs to the same module or to the same logical group. Then the next step will be to create what we call the targets using the STGT API that I talked before. So in this example, we create a target called BL31, right? And then we add the settings corresponding to the groups, default, compiler, hardware platform, and BL31 specific. And if you pay attention, you can see that, for instance, compiler and hardware plat are the groups that we defined before, which means that all the different settings and keys and values that we have here are automatically assigned to BL31 target, right? Then we specify that target is of type executable, it's a binary. And then we can pass a list of source files that have to be built into this target. Some of those can also be added conditionally. We can also add libraries we want to link to, and those libraries will become dependencies and will be automatically built if they are not. And we can add a bunch of other properties as we need. So these two snippets of code were just a couple of very, very basic examples. Build system definition is much more complicated than that because it encompasses libraries and it encompasses other modules, but I guess you get the idea with this. Okay, any questions so far? Okay, I will move forward then. So the current status of the implementation at the moment is the current framework is still work in progress, although we are very close to have an initial release. We will need to add more features to it as we continue with the migration of the current platforms. So far, we only have support, very basic support for FVP. This is internal and is still work in progress as well. Although, again, we are very close to have an initial version pushed to the public repo. Some libraries, mostly the libraries that we needed to build FVP, also have a basic support. Okay. And Okay, and moving forward to the last slide is the future plan and roadmap. So as I said, this Cmake build system is in a very, very early stage, and this is still plenty of work to do. So as I said on one slide before, we are dividing the work into two phases. One of them, phase one, will it doesn't phase one doesn't include changes on TFA code. We are at the moment here on the finishing the first half of the phase one. So the public Cmake framework repo is almost ready, and as soon as it is finished, we will make it public. The TFA build system, the first initial version with basic support for FBP, is also almost ready. I know that there has been some discussion going on through the mailing list, although I didn't have time to catch up with them. And I know that there's also some documentation published out there, although there's not much yet. We are also working on new documentation, which will be available as soon as the public CFW repo is there. And once we finish this first half of the phase one, we will have two build systems coexisting. We will have a Cmake one and the actual one. So in that point, we will start working on porting the rest of the platforms to the new build system. We will start improving the build system and adding new functionality as we need. So this will be pretty much driven by the porting process. If we need any features, we will be adding them on the fly. And then once we have pretty much all the platforms ported, and once we have all the libraries and everything moved to the new build system, we will make the GNU Make build system deprecated. In this, there will be a period of time in which both build systems will be living together, but with the Make build system deprecated, and then we'll eventually drop the support on that. And then the second phase of the porting will consist, as I explained before, in refactoring all the code on TFA to make TFA code more modular and to help the new build system to make use of all the Cmake features.
Right.
That will be pretty much that is pretty much the future roadmap. So here we are a little bit behind of this schedule here. The first half of the phase one should have been complete by first quarter of 2020. It is almost there, but we are not there yet. And then the deprecation of the current build system was originally planned by quarter 3 of 2020. I don't know if we are going to be able to get there. This might be slightly delayed. Next quarter, last quarter of 2020, of 2021, we don't know yet because this is still in the air. But yeah, that was pretty much the whole presentation that I wanted to give today. And if any one of you have any question, I'm happy to answer. Thank you.
Xavier, anyone has any questions? Okay. So, Javi, can you give the control back?
Yes, is it back?
Oh, yeah. Okay.
Okay, cool.
I want to ask, you gave the timelines, and Q3 of 2020 is seems like when when TFA starts enforcing Cmake. Is that right?
Sorry, can you repeat the question, please?
I'm looking at timelines, and you say Q3 of 2020 is when Cmake is enforced. So there's no support for Make, right?
No, well, that was the original plan, but we think that is going to be extended later for longer in the future, because I don't think we are going to make it by then. So there's going to be a period of time, we don't know for how long, in which the current Make build system and the Cmake build system will live together. So actually, there won't be any kind of problem having both build systems at the same time, because with the Cmake framework, we would be able to run to build the system in a separate directory from the sources. So it won't suppose any kind of problem if we have both at the same time. So we won't remove the Cmake build system from there. We will probably just stop supporting it and leave it die. But I don't know yet. We have to make a decision on this. But this is not something that is going to happen very, very soon. And also we will, before this happens, we will announce that on the mailing list. We will leave enough time for people to port their platforms. And also we will have a better documentation than we have now by then.
Right, and the way they will work together is that the make file that Cmake will generate will link in the make files of specific platforms. Is that right?
Sorry, can you repeat that question? I didn't get it.
Sorry, the way that Cmake and traditional current make system will coexist is that the make files that Cmake will generate, those make files will then link the platform platform make files.
No, not exactly. So the platform make files that we have now, they won't be used for the new build system. So the new build system will generate its own completely different set of make files.
Right, but when you say the existing make file system will coexist with Cmake, does that mean that they will exist in parallel, or will they work? So some of the make files that are generated by Cmake will also use existing make files, or will there be two completely different make systems?
No. There will be two completely different and independent set of make files. So
right,
because we can with the new framework, we will be able to build with the new framework, we will be able to create a build system in a different directory from the sources. So you can have the TFA source in directory A, and then you can go to directory B and generate the whole build system there with its own set of make files and dependencies. And all those make files will point to the source files and to the libraries and to the modules on directory A, where you will have your sources for TFA.
Got it.
Okay.
Thanks. Yeah.
So please let me add some details. So short term, the plan is to have the two systems live in parallel. And longer term, the expectation is to move all the platform builds over to Cmake. How this exactly will happen is an open question. we might have a period where the legacy build system could be started from the Cmake build, and that way the porting can take a longer time. But all these details are not decided yet.
Thanks, Mark.
Okay, any other questions? Okay, so yeah, hope you can see my screen. Actually, I pulled the like the threads in tf.org emails. So just wanted to check if anyone had any particular item from here to be discussed, either like the end of April or May threads.
I do have a question. I don't know if it's covered in the mailing list here. If nobody has a question, I can fill in with my independent question, if that's all right.
Yeah.
I wanted to know your opinion on code that people don't want to, open source. So if a particular platform doesn't want to open source parts of its code base, and that will probably be, obviously that will be inside plat directory, but they still want to use and keep up to date with TFA, so they want to upstream as much as possible from platform directory, but they don't want to share all the code. Is that something that you guys are thinking about?
I think they already do that for ARM already does that for CryptoCell. So most of it is open source, but the CryptoCell library itself is not. So
Is that linked as a binary?
Sorry?
I was going to say, is it linked as a binary? So is binary part of the source code?
That's my understanding.
Hey, it's Matteo speaking here. Just
So,
to comment on this. Hey, can you hear me?
Oh yeah, yeah. Actually, I was trying to call it. Yeah.
Yeah. So my comment here from a board perspective, from a TF.org perspective. So the project obviously is not recommending platform ports which has binary blobs in it. That's not in the spirit of the project. And it was also discussed at the board and TSC level, we should discourage platform ports in the code which has proprietary pieces in it. If for very special reason, a partner would like still to go ahead and propose a platform port which has some proprietary pieces, I guess we should discuss that, at least at a TSC level. It was discussed for a special case, and the special case was, so the company that was trying to promote this special case was suggested to host their own binaries on their own repos, so not hosting binaries on tf.org itself. So tf.org should not host third-party binaries. If during the build process, the specific scripts in the platform code pulls some binaries from outside, that's probably still fine as long as it's well documented, but we don't really want tf.org to become a hosting site for third-party binaries.
Right, that makes sense. Thank you.
All right, Matteo, this is Julius from Google. I think the case you discussed was sort of special because the license in that case was not acceptable to what we were willing to host on tf.org. But I think we still have that process of hosting binaries in that special TF binaries repo which we created, so we could still use that, right? That process was approved by the board, and I think the board would probably be willing to use it going forward. Like, we didn't remove that process, we just decided that for this one case that wouldn't be possible. So to the person who asked the question, if you look in the contributing.md file or RST or whatever it is in the docs repo, I think it describes how to use this TF binaries repository that we've created. And there are some rules in there about what kind of, like, what the license needs to allow people who download the binaries to be allowed in that repository. And I think if you comply to those rules and you apply for having permission to have a binary in this repository with the board and the board agrees, then we could use that process for new platforms. So I would suggest to check that.
Yeah, thanks, Julius. Actually, I did forget about that step. So for the special case I was referring to, yes, you're totally right. Not only they were proposing a binary, but the binary was also carrying a license that was not within the accepted typical BSD binaries, BSD licenses from the project. So that raised all the concerns. But yeah, Julius is totally right. So there is a process and there is a repo in case partners really want to go down that path. Still not the preferred option, I would say, but there is a kind of an alternative for these cases. Yeah.
Sure. Thanks a
Does
lot.
that apply to header files too? Because the CryptoCell example, right? Yeah. So I see some proprietary CryptoCell specific headers that's been checked into the code, right? Or is that only binaries and you don't care as much about headers?
I guess headers should be okay as long as they have permissive license. Don't see why there should be problems.
Okay.
Now, I can't remember the specific case of CryptoCell, but I don't see them being an issue as long as they are, well, open with a permissive license.
Okay. Yeah, because so for CryptoCell as well, I see, so CryptoCell 713 or whatever, yeah, I see there's no binary for it, but I only see the header files, right? So it looks like that's the model that is accepted by the code base. So yeah, the binary isn't hosted on trustedformat.org, but yeah, you've got a bunch of headers and you've got the project that links to a binary that does not exist in the repository.
Yeah, that's probably right. I think we probably have to confirm offline. Maybe you want to take an action and confirm next time.
Yeah, I already took it down.
Great, thanks.
Yeah. Okay. Any other topic? If there is no follow up on any of these email threads.
Hi, Varun Wadikar here from NVIDIA. So I have two questions. This is not related to the email discussions on the mailing list, but there are some topics that I think Joanna touched upon in one of the previous meetings. The first one is opening up. I think she had talked about opening up of the internal build logs to the community. So if you can talk a little bit about that effort, where we are and what's happening there. And the second one is the opening up of the platform testing framework. I think you call that Lava, if I'm not mistaken. So opening up of that to the platform owners so that they can hook in their platforms. So if you can then talk a little bit about this, that would be really helpful. Thanks.
So Mark, you want to take this up? The OpenCI.
Shoot. Yeah, can you hear me?
Yeah.
Yeah. So so the effort that we're currently engaged in with the OpenCI is we're attempting to have the internal CI that we have on our side in congruency with what's going on with the Linaro side. So we'll have at some point the CI entity itself complete open source. So we'll have all everything that we have for the changes on our side be able to be pushed there transparently. So that'll be probably happening within the next, say, 6 months or so. That's what we're hoping. That's the target for that. That should be happening relatively soon. So we're working actively with Linaro now to make sure that that happens. That open sourcing will actually be there. Does that make sense?
Okay. Yeah, just to confirm, when you say OpenCI, it talks about the build logs as well as the testing farm, right?
Yes.
Okay, thanks.
And Varun, just to confirm, so Lava is an acronym that Linaro uses for their own testing infrastructure. I guess it stands for Linaro Automated Validation, whatever. It's effectively the framework they use for invoking scripts on a target and for linking all the pieces together. So the compilation, the artifacts on the compilation going into the target, triggering some tests, getting the results and feeding the results back. So the whole framework that Linaro uses is called Lava. That's it.
Okay, thanks, Mattia.
So any other questions? Okay. So if there is no questions, we will call it a day. Thank you all.
Thanks. Bye.
Thank you.
Thank you.
Bye.
Thanks.